Hi, I'm
Uh,
Alyssa, and we are going to talk about our lesson plan. Um, Bradley's going to talk first, just kind of give an overview about it, and then I'm going to talk about the specifics and how it run in the classroom.
so I'm Bradley, and we decided to do a fifth grade lesson plan over graphing. Uh, we wanted our students to successfully code a robot to travel to a specified point on a coordinate plane. The standard we used was graph ordered pairs and label points using the first quadrant of the coordinate plane. Understand in the ordered pair that the first number indicates the horizontal distance traveled along the x-axis from the origin, and the second number indicates the vertical distance traveled along the y-axis, with the convention that names of the two axes and the coordinates corresponding. So that says a lot. It pretty much wants us to talk about the x-axis and that it is the horizontal number that runs across the center of the coordinate plane, and the y-axis, that's the vertical number that runs down the center of the coordinate plane. And then it wants us to talk about the origin, which is the intersection between the y and the x, and the quadrants, which are 1, 2, 3, and 4. Those are numbered counterclockwise using Roman numerals, and what ordered pairs are. And to use that, to put that in what we're wanting to do, we need a rover TI robot that connects to a graphing calculator and drives based on the calculator program. A program is the overarching commands that are used to move the robot, and a sequence strings those together to get a certain outcome. What we're wanting them to do is use all four concepts of computational thinking. They have to create the code and move it along the correct spot of the coordinate plane. And then they will also utilize decomposition. They will break down the problem and determine how to get them to the correct spot. They will then use pattern recognition to help them determine what sequences to use to get them to the outcome that they want. And then they will use abstraction to create basic principles of the rover's movements. For example, move rover to the right 2 or up 3 or 4. And then they will use algorithms that strings the code together, and pretty much that will use all four steps to get them to do what they need to get the coordinate ordered pairs correctly. First, before we even start our lesson, we will have to do a pre-assessment. And for that, we're going to have a worksheet made out, and it's going to have basic questions like, what is an ordered pair? Where would this ordered pair be on the graph? And stuff like that, just to kind of see if they know anything about it. And if not, it's okay. And if so, great. We can work with that. We will start with the hook. The thing we will do, we'll have them partner up. We'll blindfold one partner and have the other partner stand across the room and tell the other partner to move and get them to a certain spot. And that will kind of show them before we give them the robot how to tell someone to move, which will in fact tell the robot to move later on in the lesson. The real world connection, it teaches the students how to code and lets them know a little bit more about computer science and coding and plotting data. And for reflection at the end, we will have students write a paragraph of what they learned, what their favorite part was, and what they want to learn more about. For the assessment, we were going to give a quiz that asked them to write out the code for 10 specific ordered pairs. And then each student will have to do a certain ordered pair for a participation grade. And our formative assessment we will guide the students in creating 5 example codes, and we'll walk around and monitor how they use their rover robot. And we will also look at their code to see if it is correct. The evidence we will use is an essay. Can't really see the other, sorry.
I think it says short answer.
Yeah, okay, short answer. And if students get 7 out of 10 correct on the quiz, then that's considered mastery, and they will receive 100 for the activity. And then the assessment requires students to organize, make generalizations, produce arguments, life experience. I don't really, can't really see that on my computer.
Yeah, it's a weird format. All right, I'm going to talk about and break it down and kind of talk about how we would use it in the classroom. Before I do that, let me just show you. This is what a rover looks like. The calculator just sits right on the top there, and you'll do the code. You'll put the code in before you attach the calculator, and then the robot will run the sequence that you code. So it's pretty neat. What we will do for our academic feedback, each student will receive their quiz back with corrections and feedback on problems that were marked wrong. They'll also receive face-to-face feedback and teacher assistance when they do their coding demonstration for their participation grade. So for the actual lesson, during the first 30 minutes of class, we will do our icebreaker, where the one partner will guide the other one to a marked location, and they'll do that one instruction at a time, just like code is one line at a time. And obviously the other one won't be able to see, so they have to be specific about their instructions. This helps them with their computational thinking, just thinking about how code works. This exercise aligns with the teaching of the principles of computational thinking, like I just said, get students thinking about algorithms and sequencing. I will ask questions regarding their thought process and how they could have done it better in order to create better code later on when we do the activity. I'll ask them to start at the solution, which is where their partner is going to go, and work backwards to the problem in order to determine the best way to solve it. You will need a blindfold and tape to mark the spot for that section. Okay, to transition to the next part, students will return to their seats, and the teacher will pull up the PowerPoint on coding and the coordinate plane. So the PowerPoint will kind of give them a refresher on graphing these points, and it will give an introduction on coding and this way of thinking that we're asking them to do. During this part, I will have the students complete a self-evaluation regarding their knowledge of graphing. They will graph 5 different ordered pairs on their own to refresh their knowledge about graphing. I will also complete these on the whiteboard to help them check their answers and make sure they are ready for the lesson. So this gives them a moment to look at what they're doing and see if they're on pace with what we're going to be learning. So they don't know how to graph, it'll be really hard to apply that when they do the robot. I will then do a quick lesson on the rover and how it works. I will go over how to use the rover program and how to sequence the commands in order to move it. I will do 5 sample coordinates and code on showing how to move the rover, and then I will group the students in groups of 4 and let them play and experiment with the rovers with practice problems. The rover basically has its own program. You just have to learn how to type in the commands. So the commands would be like move rover forward 1. or move rover backwards to, or turn rover to the right. So they have to think about the sequence in order to get it to the right spot. This portion of the lesson requires students to employ their knowledge of graphing in order to program the rover to move to the desired position. It also requires their knowledge of sequencing ideas in order to get a desired outcome. I'll ask questions about sequencing and holes in code that may interfere with the running of the rover program. So I may type an incorrect code and show them what happens if they type it incorrectly or they leave a hole, so that will help them not make those mistakes when they do it. You'll need a rover and a graphing calculator for that part. And obviously you'll tape out the coordinate plane on the floor and have the rover go on that coordinate plane. To transition to the end, students will return to their desks to complete the assessment. So after they've kind of played with it and they understand how to use it, as I'm walking around and watching them and giving them feedback, they'll do the assessment. And I will hand out the quiz that asks students to write out code that they would employ for 10 different coordinate points. So it would ask them, how would you get the rover to move 2.45? And they would have to write out the lines of code that they would type into the calculator. They will each have to code and demonstrate one ordered pair for a participation portion of their quiz. So they'll come up one at a time and they'll pick one of their ordered pairs off of their quiz, and they'll actually type in that code to make sure that it works, and they'll get a participation grade for that. They will have a prompt at the end that they will take home that asks them to write one paragraph about the lesson, what they enjoyed, and what more they wanted to learn. And this will take 20 minutes, this end portion. And it will allow for the assessment of the objectives in order to observe mastery of the related standards. And you'll just need your worksheets for those things. The technology that we're using is a PowerPoint, graphics, charts, coding platforms, the interactive whiteboard, which is where you put the PowerPoint on, and obviously the rover and the graphing calculator. The strategies that you're using as a teacher are modeling, cooperative learning, independent learning, and implementing pre, post, during lesson activities, teaching metacognitive strategies, hands-on learning, higher order thinking skills, real world connections. So there's a lot of practices being used in this lesson because you're modeling for them, you're doing a PowerPoint, you're putting together code and the lesson that you're teaching, and it kind of comes full circle. Why we chose to use the rover is because it allows students to physically see the concept of graphing while physically seeing the outcome of their coding. So instead of just writing it down or plotting the points, they actually see this robot moving and moving to those ordered pairs as a result of what they coded. So it helps them just visualize it. I use the whiteboard to model the code and the graphing, so that PowerPoint at the beginning. And I used the coordinate plane, which was the graphic, and I taped it on the floor to be used in conjunction with the rover. We did individuals, pairs, cooperative, and whole groups. So at the beginning, they were by themselves. They worked by themselves, and then they worked in a small group, and they paired up to do their self-assessment. So they were moving a lot, which is really important for a good lesson. How we would accommodate students with learning disabilities is that we would group them with students that are more advanced so they can receive more help. And we would make sure to provide more individual attention to ESL students or those who are visually struggling with the CT and the coding. We chose this strategy to teach computational thinking based on the idea that students learn code better when hands-on learning is provided. Many educational websites support the teaching of computational thinking in conjunction with math and prove that sparking their interest and molding their ways of approaching a problem are vital for the teaching of computational thinking. And that is our lesson plan. Thank you.